2019, paper 1. Question 1. What is 1 microsecond? So micro is equal to 10 to the power of minus 6. Okay, so 6, if we zoom in, 1, 2, 3, 4, 5, 6. Here, answer is B. Question 2. A speed time graph of an object is moving in a straight line. It's shown. So you have a speed, and then you have a time, t. So how far does the object travel in 50 seconds? D, question mark. So as we know, the area under a speed time graph equals distance. So you just calculate the area here, which is equals to half times 20 times 20 plus the area here. So 20 minus 50 is 30 times, again 20 here. You get 600. So you get 800 meters. Answer C. Question 3. A car travels forward along a flat road. All the horizontal forces that act on the car are shown. So there is an air resistance, 1000 newtons. There's a frictional force. Let's use small letter f. There's a driving force, 300 newton towards the right. Okay, so since the car is slowing down, it means that the driving force is less than the frictional force and the air resistance. So 1000 air resistance plus frictional force should be greater than the driving force of 3000. So you can solve for F, more than 2000 newtons. Question 4. An object is moving at constant speed. So it means there's no acceleration. Acceleration equals 0. F net equals to ma equals to 0. Okay. So what force must be applied to change its motion? Why does a force need to be applied to change motion? It's because the object has inertia. The reluctance to change its state of motion. Okay, question 5. A rocket has a mass of 15,000 kg. When it's on the moon, it experiences the moon's gravitational field strength of 1.5 Newton per kg, small g. What is the weight, question mark, of the rocket on the moon? We know the formula. Weight equals to mg equals to 15,000 multiplied by 1.50, which will give you 22500 newtons. Question 6, not tested. Question 7, not tested. Question 8, a man eats his breakfast, so CPE, chemical potential energy, and later goes for a run. Run, motion, kinetic energy. Which energy takes place as a man accelerates? So A, CPE converted to KE. Chemical potential energy is destroyed. No. Conservation of energy states that energy cannot be created or destroyed. So C and D is definitely wrong due to the conservation of energy. Okay, next. Question 9. A force used by the engine to drag a log along a smooth ground and then over a rough ground is represented in a bar chart. What is the work done by the engine in dragging the log? So as we know, work done, W, question mark. You have force, you have distance moved, which is S, displacement. You know the formula for work done equals to force times displacement equals to 10 times 10 plus 15 minus 10 is 5 times 20. Answer 200 joules. Question 10. Air molecules are trapped inside a metal container. What happens to the air molecules when the metal container is heated? So when it's heated, your temperature increases. What you can do is you can draw the box. Okay, the before and after heating. So before and after, same 3 molecules of gas. Initially, the velocity is small, but after it's heated, velocity is larger. Okay, so then they move faster. Remember, it's the same number of molecules. Okay, there's 3 before, they never add more gas. The molecules do not get bigger, they stay the same size. And they actually vibrate more, because more energy. Higher temperature goes to higher Ke, higher velocity. Question 11. 4 identical copper containers are coated and set up as shown in diagrams. They have equal volumes of water at 80 degrees C, and they are left in a room which is at 20 degrees C, which means heat will transfer from a hotter to a colder region. Okay, after 5 minutes, which container will have the coldest water? So as we know, black and down are good emitters and absorber of infrared radiation. Polish and silver, they're the opposite, so they are bad emitters or absorbers. Okay. And now with a lead, you actually prevent convection currents. So A will be the one that has a good emitter and doesn't have a lead. Question 12. Which rule describes a liquid at room temperature and pressure? So how you draw a liquid? It should look without a fixed orientation. Okay, so they do not have a fixed shape, but they have a fixed volume. Question 13, a wave travels across the surface of water. Which name is given to a line joining all points in phase? So wave frequency is F, wave speed is V, formula equals to F times lambda, and the answer is actually wave front, connecting all the points, especially for a surface, for water, the ones that you can see is actually the crest. Wavelength is lambda. Question 14. Which rule describes the property of electromagnetic waves? So as you know, EM wave does not require a medium to travel in. And that's why they can actually travel through vacuum and they can travel through air. Whereas longitudinal wave cannot. So it is a transverse wave. A fishing boat uses equipment that produces sound to detect shores of fish below the boat. The fishing boat will receive an echo from a shore of fish, time 0.8 seconds after the sound is sent. The speed of sound in water, V, is 1500 meters per second. How deep is the shore of fish? So as you know, for echo, the sound will hit the fish and bounce back. So it's 2D. If D is from the boat to the fish, you will transverse a distance of 2V. So for echo, V equals to 2D over T, distance over time. V was given as 1500 equals to 2D. We're trying to find how D question mark. Time is 0.80. You can solve for D equals to 600 meters. Question 16. Which statement correctly defines current? formula was Q equals to IT. So current is actually equals to the charge over time, the rate of flow of electric charge, not electrons only, but electric charge. Question 17. A circuit containing 3 resistors X, Y, Z is set up. Which formula can be used to find the total effective resistance of the 3 resistors? So initially, if we were to redraw it as X, Y, and Z, you realize it's actually a series plus 1 in parallel. We solve for the parallel first, call it R1 is equals to 1 over Y plus 1 over Z. 1 over R1 equals to 1 over Y plus 1 over Z. R1 will be equals to inverse like this. Okay, so we can redraw it as X R1 now. And we solve one more time. R total in series will be equals to X plus R1, which is equals to X plus this one here, 1 over Y plus 1 over Z inverse. Okay, we write it to the easier form. Answer D. Question 18. The circuit is shown below. There's a battery, EMF. There's a lamp 1, lamp 2. You give V1, V2 for the voltage of lamp 1, lamp 2. Which statement is correct? In a parallel circuit, we know that EMF is equals to V1 equals to V2. Here. Question 19. The diagram shows the wiring in the mains plug. So we have done this in class. What is connected to the fuse is the live wire. Here, Q is the earth wire. P is the neutral wire. So for the neutral wire is blue. For the earth wire is green, yellow stripes. For the live wire is brown. Question 20. The lighting circuit of a house is connected to a 230 volt mains supply, so V, through a 5 ampere fuse. Okay. The number of lamps rated at 100 watts are available. What's the maximum number of lamps that can be used in this circuit? So it's given you P and V. You can use the formula P equals to VI to find the max current. 100 equals to 230 times I. I will be equals to 0.435 ampere, and this is per lamp. So for every lamp, it will use 0.435 ampere. So now the question is, for a 5 ampere lamp, 5 ampere fuse, how many lamps can you attach it before the fuse blows? So you can take 5 divided by 0.435, which will give you 11.49. So usually you round up. But the thing is that when you round up to 12 lamps, then it will be more than 5 ampere of fuse. And then you burn the fuse. So actually you have to round down. Okay, to 11 lamps only. C. And that's the end of the MCQ.